This is the first of two videos talking about scaling of images. This one is going to present the concepts of scaling down and then scaling up an image, and the second video will actually look at Python code to do the same. So let's look at the concept of scaling. I have on the screen a made-up geometric sort of design that is made up of a variety of colors. And I'm wanting to imagine that these squares of colors represent individual pixels. So this is a very small 6 by 6 pixel picture. And as we're familiar, the x-coordinate values are going to have values of 0 through 5, and the y is going to have values of 0 through 5. So a total of 36 within the image. Let's imagine we want to reduce this picture to half its size in both dimensions. So we'd have 3 horizontal and 3 vertical with indexes of 0, 1, and 2 for a total of 9 instead of the 36. So the simplest way to do this scaling down, since we're scaling by a factor of 2, we're going to take every other pixel and move whatever color it is to the new picture. So for instance, we'll start here at 0, 0 in the top left. I'll copy that, come over here and paste it in. And then let's just work across the row. So the next one, I'm going to skip the 1 and go to 2. Copy it, paste it. Skip the 3, go to 4. Copy, paste. And that completes the first row. We've taken 0, 2, and 4. We've taken every other pixel. And we'll do the same thing going vertically. So we're going to skip over the second row with a y value of 1 and pick up this gray cell. So we'll copy that, and that's going to go here. Skip over the second gray, get the yellow, skip over the second yellow, get the gray, and again we skip over 3 and go to 4, and we copy those in. And we end up with that as our scaled down version of our original. Now just to take a quick glance at them, it still has the same colors, but it is a significantly different appearance compared to the original. There's not really a great deal of symmetry in the new one. There is some in the original, but if we're reducing the number of pixels in each dimension, we have to leave out some of the data, if you will. We have to leave out some of the colors. And so, as I said up front, the simplest way to scale down a picture is to simply leave pixels out. And since we were scaling by a factor of 2, we took every other pixel. Let's take a real quick look at what it might look like if we did it by a factor of 3. In other words, it's 1/3 the size. So instead of having a 3 by 3, we're going to have a 2 by 2. So let's do the same thing. We'll grab the first one. Let's put it right here. And then since we're doing it by a factor of 3, we're going to skip over 2 and take this one. And it would go there. And that's as many as we're going to do because it's just going to be a 2 by 2. Come back to the original, skip over 2. We come here. And we come here. So again, we still have most of the colors. We've lost the red in this case, but that would be a drastic scaling down to 1/3 of the original size. Now obviously if we're working with a bigger picture with hundreds of pixels in each dimension, skipping every other picture or skipping 2 out of 3 pixels is not going to create as drastic a change in the image as what this does. We're working with a very limited number of pixels here, but perhaps obviously I didn't want to do this with thousands or millions of pixels as a demonstration. So hopefully you get that idea. So the bottom line takeaway here is we're going to skip as many pixels as we need to based on the factor of the scaling. When we were scaling by a factor of 2, we skipped every other. Scaling by a factor of 3, we picked up every third. We skipped 2. So let's take a look at what it would be like to take this small image and scale it back up to its original size. I'm going to jump to another tab where I've already got the the beginnings here, but then I've got a grid laid out. We're going to do something called the nearest neighbor interpolation. Interpolation basically means creating something based on what you know. So the idea is that for a given pixel that we move over, we're going to use the same value multiple times. We're starting with a 3x3 grid, 9 pixels, and we're going back to our original size of 6x6, total of 36. So the question will be, if we take this scaled down version that we did the first time, will we get this original picture back? Our method's going to be to copy this. Again, we're scaling by a factor of 2. So I'm going to put it in here twice. I'm going to put it there and right next to it. And then I'm going to do the same thing vertically. So that single pixel of yellow has turned into a block of 4 pixels. And then I'm going to do the same thing with the blue. I'm going to put it in these 4 spots. And the same thing with the red. So the top row looks the same, it's just twice as big in both dimensions, which is what we're wanting to do. We'll come and grab the gray, and it's going to go in these 4. The yellow is going to go in the 4 in the center, just like the center pixel was to begin with. And here. And again, we're doing 4 because we're doubling it in both dimensions. We're putting it in the original spot, and then the one to the right, one down, and then the diagonal. And to fill in the last row, we have red, we have blue, and then we have the orange. So again, to look at this finished 6x6 and compare it to the original, it doesn't really look the same. But if we compare it to our reduced version that we started with, I think you would agree it does look the same. It's just twice as big. And so in the case of scaling down, we lose some data. We don't have any way to reverse that process and get exactly the same image back. But if we were to take this image, where we scaled it up from the small and scaled down, we could end up with this version here, because we know what the algorithm was to get here, and so we would just pick up this one, this one, this one, and that would match that row. Scaling down loses data, and if we reverse that and try to scale it back up to the original, we don't get the same thing back. But if we take something small and scale it up, take it back to the original size, we can end up with exactly the same thing. So in general, using this method, scaling up is lossless in that we can reverse it and get back to the original size, but scaling down is lossy because we cannot reverse it to get back to the bigger size and have the original image. We'll see you in class.